Hi, so the last little section here in the intro we're going to talk about is experiments. So last time we talked about observational studies. We learned that in an observational study, you don't actually control a lot of the stuff going on. You don't control variables, etc. You're just kind of observing what goes on and collecting the data. So then the other way to collect data is through an experiment. So an experiment is very different than an observational study. And here's what we're going to have for our definition. So in an experiment, it's a study where the researchers assign treatments to cases. So that right there is our definition for our experiment. So with that being said, so we're controlling the groups. We're controlling the variables. We're controlling the groups. So there are actually four major parts in an experiment we need to think about. So the first one is exactly that. Control. Right, so we need to control everything that's going on. So we should divide our groups or our subjects into at least two groups, a treatment group and a control group. And we should have one variable that's different between them, the thing we're trying to measure. But everything else should be the same. So say that you're testing a drug. You're trying to see, does this drug have adverse effects or not? So one group takes the drug with a little bit of water to wash it down. The other group, you should have probably some sort of placebo, and they should also take the water as well. So you should try to keep everything else as similar as you can, just changing that one variable. The next thing is randomization. So you should have some randomization between your group. And by that I mean when you pick your groups, you should do so randomly. Right? You shouldn't pick all of one type of person in this group and everyone else over here. You should have some random way of picking your group. So maybe you flip a coin. Maybe you have a random number generator, something to make sure that your groups are chosen randomly. Because you don't want to have anything else affect the results except for the thing that should be affecting them. Final, or third thing, is what we call replication. So whatever results you get should be able to be replicated. So if somebody else runs your exact same experiment, you should have all the notes to tell them how to run the experiment. If they run it, they should be able to replicate your results. And their results should be similar to yours if you've done your experiment correctly. If their results are completely different, then probably your original results and the new results don't mean anything at this point. So you want to make sure your results are replicable. And then finally, and this doesn't happen always, but it does happen enough, this thing we call blocking. So the idea of blocking is that you actually have another variable you think might affect the outcome, and you do this thing called blocking in order to take care of that. Essentially, you divide them into two separate, or your participants into two separate groups based on this other variable. And then within those groups, you randomly designate them as a control or a test group. So one way with blocking, maybe you're looking at a new drug, and you're trying to introduce it to the market. So you might block them, I don't know, maybe you have high cholesterol and then low cholesterol. Right, so before you've even divided them up into their treatment/control group, you divide them into these groups: high cholesterol, low cholesterol, and that's based off of the participants. And then from these, you divide them into your treatment group and your control. And when you divide them there, you should do so randomly. Right? You shouldn't, after you divide them into those two groups for your high cholesterol, low cholesterol, you should randomly divide them into your next group, treatment control. And we usually refer to our main groups as that, as the treatment group and as the control group. So if we designate our two groups like that, your treatment group is exactly that. They get some sort of treatment, right? So the treatment group in a drug study would get the actual drug you're testing. right? And then a control group would not. However, the control group would usually get something we call a placebo. So a placebo, you can think of it as being a fake drug, right? Usually like a sugar pill or something. So you give the other group a placebo in order to make it so they think that they might be in the treatment group, right? Because you don't want any psychoanalysis going on here where they think they're in the treatment group, and that's why the treatment is working, because sometimes that actually has been shown to work. That just because somebody thinks they gave you, or somebody thinks you gave them the drug, they might actually see the results of that. So in order to combat that, we have what we call a placebo. All right. So then kind of the last thing, and by the way, we call that, so if you give them a sugar pill and they see the positive effects, we just call that a placebo effect. Right, so that's when you see the good results even though you didn't take the actual drug or have the actual treatment. But because you thought you got the treatment, you're seeing the same results, call it a placebo effect. Usually it's because it's all in the person's mind, and the mind is a pretty powerful thing. Kind of the very last thing with an experiment is whether or not you want to make your experiment what we call blind. And typically you do. So a blind experiment, or what we mean when we say the experiment is blind, is that the people in the experiment do not know which group they're in. So people in the experiment do not know if they are in the treatment or the control group. And that's an important thing, right? Because, again, it goes back to that placebo effect thought, right? If they do know which group they're in, then you might be seeing results based off that, right? If they don't think if they think they're in the control group and they don't think they're getting the treatment, they might not see positive effects because their mind is doing that to them. Whereas if they think they're in the treatment group, even though they're not, they might still see those positive results. So you want to make sure that you have a blind study so that they don't know which group they're in, which you can't always do, right? Sometimes it's pretty impossible to have a blind study if you're looking at weight loss due to exercise, right? You can't blind somebody to the fact that they're not exercising or that they are exercising. So you can't always have a blind study, but usually, or a blind experiment, but usually if you can, you want to. There's another layer to that we call a double blind. So in a single blind experiment, the people in the experiment don't know. In a double blind experiment, both the people in the experiment and the people who are directly associated with those people don't know. So anybody who is going to have direct contact with the participants wouldn't know which group they're in either. And again, it kind of mitigates that placebo effect, right? Because now the people who are going to be in direct contact with the participants can't give away whether or not they're in the control or treatment group. And again, you want to try to keep that as anonymous as you can and as randomized as you can. So these are kind of the major parts in an experiment. Again, our key definition here for experiment is our study where the researchers assign treatments to cases. Right? So that key thing here is you're actually physically assigning these treatments to the cases, whereas in our observational study you did not. And again, our four key things here. We want control, we want randomness, we want to be able to replicate those results, and we want some sort of blocking in a lot of cases. And then, of course, when you do control things, you want to introduce a placebo, and then usually make sure your experiment is blind, if not double blind.